Hey everyone. So we're going to talk about probability distributions just to follow up on the Khan Academy video. So he created a probability distribution from the random variable probability of heads and 3 flips. And those 4 possible outcomes were no heads, 1 head, 2 head, or all 3 of them could be heads. So the probability distribution, the probability of no heads is 1/8. The probability of 1 head and 3 flips is 3/8. Probability of 2 heads is also 3/8. That's the same as 1 tail. And the probability of 3 heads or no tails, also 1/8. 1, 3, 3, 1 kind of reminds you of one of the rows of Pascal's triangle, huh? The third row. Okay, so that's a probability distribution. What we can do with the probability distribution is find the expected value or the mean if this experiment were to be repeated an infinite number of trials. Okay, so recall that the random variable is typically called x. And the probability of each random variable is the probability of x. So that's x and p of x. In this column, I'm going to multiply the random variable by the probability and get x times p of x. So 0 times 1/8 is 0, 1 times 3/8 is 3/8, 2 times 3/8 is 6/8, and 3 times 1/8 is 3/8. 3/8. Okay. By adding that column of x times p of x, we're going to get the expected value, which we denote as the sum of x times p of x. And I think when I was showing you this in class before this all went down, I wasn't including these parentheses or these brackets. I think that might help you, especially when we do the standard deviation formula. And I think that was throwing some of your calculations off. So include those brackets. That means that we're going to do x times p of x first, and then we will sum those numbers, and that's what your capital sigma signifies here. Okay, let's go ahead and sum these. Some of you may have done this already. 3, 6, 12, 12/8, and 12/8 is 1.5. Okay, and we call that mu in this case. It comes from a population. So it's the mean or the expected value of flipping the coin 3 times the number of heads we would expect in 3 flips. And remember, it's a mean. We can't actually get 1.5 heads, but when calculating an average, that does make sense. All right, so that's the mean or expected value. Now let's calculate the standard deviation. Why does that keep going up a little higher? Let's try to hit it this time. Oh, got better each time. Okay, anybody remember the standard deviation formula? No? Phoebe? Renee? Kyle? Middle row? Jamie? Who am I missing in the middle row? Nats. Well, I know one of you said it. We need the sigma again. The sum of. Oh, shoot. We don't need the sigma first. But it's not too late. We need the square root of. The sum of. I include brackets. Let me erase that. The sum. Oh, goodness. Sorry, guys. Bracket. This time we're going to square the random variable. We're going to multiply by p of x. We're going to do all that first. And what are we subtracting? Brandon? Yes. Mu squared. Okay? Well, it would be nice if we had a column, since we have a table already. Let's make a column x squared times p of x. And I think we can continue to do this mentally, hopefully. So 0 squared, x squared is 0 times 1/8 is still 0. X is 1, x squared is 1, 1 times 3/8 is still 3/8. Next is an x of 2, 2 squared is 4, 4 times 3/8 is 12/8. 3 is x, 3 squared is 9, 9 times 1/8 is 9/8. Now, we've got this much. Next thing to do is to sum what we got. Okay, the sum of this column then is 3/8, 12/8 is 15/8, and 9 is 24/8. 24/8 sounds like 3 to me. So the sum of all this stuff is 3. Now, from mu squared, 1.5 squared. Oh, goodness gracious, what's 1.5 squared? 2.25? Hopefully I got that right. That gives us 0.75. When we subtract 3 from 2.25, and don't forget, we got a square root there. I should have included in this step, so I don't forget it. And the square root of 0.75 is 0.9. Remember doing that in class? Coming back to you? Oh, that decimal will not do. Oh, I highlighted the decimal that will not do. Okay, get rid of that. What? I can't erase that? Get out of here. Get out of here. Oh, now it's too small. There we go. Perfect decimal. Let's label that up with our lowercase sigma. The standard deviation is 0.9, and the mean is 1.5. Okay, your turn. Here's what I want you to do. This is your mission for class today. You are going to construct a probability distribution. And you're going to find the mean and standard deviation of a spinor game with the following criteria. Okay, assume that these three angles are the same, 60, 60, and 60. And these are both 90. Calculate your probabilities that way. I suppose I should write that. 60 degrees each and 90 degrees each. Okay, in this top one, if the spinner should land here, you win 50 bucks. If the spinner should land here, you lose 20 bucks. If the spinner should land here, you win 5 bucks. If the spinner should land here, you lose 5 bucks. If the spinner lands here, you win 100 smackers. Okay? Build a probability distribution. Find the mean or expected value and the standard deviation. Go. Talk to you soon.